All right, good morning. Today we're going to talk about volume and density in our Unit 8. We're going to talk about cylinders and cones. So some things to write down. I should say day 1. So we learned about volume, specifically pyramids and prisms yesterday or on Friday. Today we're going to look at cylinders or cones. So a cylinder is like a round prism where I have a circle for the base, and a cone is like a round pyramid. So one thing that we learned on Friday was the importance of the area of the base. What is the base for every cylinder? Every cylinder has a circle for the base. What is the area of the base of a cylinder? Since every base is a circle, we will use the area of a circle formula, pi r squared. So I don't need to worry about, is the base a triangle, is it a rectangle, is it a square, is it a trapezoid? It's always going to be a circle. So the information that we have only covers the base, using the image above and the information that you have. Looking at the volume of a prism from Friday, the volume is equal to the area of the base times the height. But since I know that the base is a circle, the volume of a cylinder will be pi r squared h, always. So I need the radius and the height. And the height, again, will be the difference between the bases, and the bases are the circles. So I've got some examples here to look at. No need to draw these. If you would just, go through and write them down with the numbers and look through them. This video is going to be posted on my website, so you can always go back and watch it there. But looking at this first example, my radius of the base is 3 centimeters. The height of the cylinder is 10 centimeters. So my volume is equal to pi times the radius squared times the height, which is 10. I've got to square the radius before I multiply it by the height. So I have pi times 9 times 10. So altogether my volume for this is going to be 90 pi centimeters cubed. Please leave the pi symbol unless it tells you to round, but it's just easier, more exact, and make sure that you have your units and they're going to be cubed. Looking at the second one, this is what we would call an oblique cylinder. It is oblique because it is not straight up and down, but I do have the height here. If I had this value here, this would be called my slant height, which is definitely longer than my height. Good old Pythagoras taught us that, because I would have a right triangle there. But in this picture, my radius is not 18. Be careful. My radius is 9, and then my height is 14. Both of those are in inches. So when I use my formula, I'm going to have pi times 9 squared times 14. I'm going to square the 9, so pi times 81 times 14. I'm going to need a calculator. 81 times 14 is 1,134. There's a pi, and I have inches cubed. So even if your cylinder is not straight up and down, it still has a height that needs to be perpendicular to the base. If I were to put the height in here, it would be perpendicular, and it would still be 14 inches. Okay? So looking at this third one real quick, my radius is 5 centimeters. My height is 10 centimeters. So my volume is pi times 5 squared times 10. So I have pi times 25 times 10. So my volume here is 250 pi centimeters cubed. And again, on this fourth one, I give you the diameter. Please be careful. My radius is 13 inches. My height is 9 inches. So my volume is going to be pi times 13 squared times 9. And we get a volume of 1,521 pi inches cubed. So cylinders are like prisms, they're just a little bit easier. So I've got a little graphic here looking at a cone versus a cylinder. So a cone is like a pyramid, but it has a circular base. So it takes 3 cones to fill up a cylinder with the same radius and the same height. So got some stuff here. Let's just get down to the nitty-gritty. Please write this down. The volume of a cone is equal to 1/3 pi r squared h. So if you remember the pyramid, was 1/3 area of the base times the height. In my cone, my base is a circle, so this is where the pi r squared comes in. So I've got some examples here in looking at the volume. So looking at this first one, my radius, be careful, this entire distance is 4 meters, so my radius is 2 meters. My height is 6 meters. So my volume, 1/3 pi times the radius squared times the height. So my order of operations, I definitely need to square first, but I can do 1/3 times the 4 or 1/3 times the 6. It kind of just depends. So I'm just going to put them all together. So I have 1/3 times 4 times 6 times pi, which ends up giving me 8 pi meters cubed. For this second example here, my radius is 6 centimeters, my height is 15 centimeters, so my volume is going to be 1/3 pi times 6 squared times my height of 15. I'm just going to rearrange for my numbers first. 1/3 times 36 times 15 times pi. We have 180 pi centimeters cubed. This third one, if you're going to write down an example, this is the one to write down in your notes. Feel free to pause the video if you want to write it down. It is not too hard to draw a cone. Let me show you a quick cone. I like to start with the triangle, and then I make a circle down here at the bottom, so the back side of the circle is going to be dotted, the front side of the circle is going to be solid. So I need my height in there. It's going to go from the top straight down to the center, and then I'm given the diameter. Okay, so in this example, my radius is not 20, it's 10 millimeters. I don't know the height. The height is going to be this distance here. But what I have in this triangle, or in this cone, is a right triangle. So the height is what I need. I know this outside length is 26. This is called my slant height, which is going to be the hypotenuse, so it's going to be longer. And then this distance down here, which so nicely represents the radius, which is going to be 10 millimeters. So good old Pythagoras told me that I can use the Pythagorean theorem anytime I had a right triangle to find a missing side. So I'm going to use the Pythagorean theorem. I'm going to do it down here. So h squared plus 10 squared equals 26 squared. So h squared plus 100 is equal to 676. So if I subtract 100 from both sides, h squared is equal to 576. And if I square root that, I end up with 24. If I hadn't ended up with a nice whole number answer, I would either want to round to 2 decimal places or use the radical value. So the height of this cone is 24 millimeters, which definitely is shorter than the outside edge, so it kind of matches up with what I was expecting it. So my height is 24 millimeters. Please watch out for these kind of problems. Though you'll probably see one on the milestone. It's not hard to find the volume of a cone, but if you have to evaluate what is the radius and what is the actual height, because they're giving you the slant height, it increases the depth of knowledge, the rigor of it, and they're probably going to ask you like that on a milestone. So volume is equal to 1/3, oops, pi times the radius squared times the height. So 1/3 times 100 times 24 times pi. 800 pi millimeters cubed. That's a tough one. Write it down. All right, and then my fourth one, my radius is 2 miles. My height is 5 miles. So I just plug it in. This does not reduce nicely. I'm going to write it as a fraction. So I have 20/3 pi miles cubed. If you are a decimal lover, it is acceptable to have it as 6.67, fill a line over it, pi miles cubed. All right, so your assignment for today, I have homework on a practice on cones and cylinders and then all different kinds of volume. One thing that we did not talk about, and it's on the homework page, is a sphere. A sphere is a three-dimensional circle. So the easiest way to draw a sphere is to draw a circle on the outside, and then you're going to draw like the equator that goes around. So I need an oval shape here. The nice thing about a sphere is that there's one radius. There's only one measurement for the whole thing. I have a radius. So that is the distance to the right. It is also the distance to the top, and to the left, and to the bottom, and out to any side inside of my sphere. Think of a globe. The volume of a sphere is equal to 4/3 pi r cubed. So whatever the radius is, let's say that this radius is 6 centimeters. So to find the volume, we have 4/3 pi times 6 to the third. Let me just check my 6 to the third. It's 216 pi. So essentially this is 4 times 216 divided by 3 with a pi. And that reduces to 288 pi, and then I need my units, centimeters cubed. All right, good luck.